In this video, we will use the visual and mathematical representations that we learned about to try and solve some problems involving our first chemistry relationship, which is density. So in our first problem, we know that aluminum contains 3 grams for every 1 milliliter. That sounds like a relationship to me because we've got two quantities that are related to each other, and we're given the volume, which is 5 milliliters. And it's asking us what is the mass of the can. So first I'm just going to strategize how to solve the problem. I need to get to the mass. So my goal is to get to mass. I know the volume. And the relationship between the two is density. So I'm going to use density in some way to get the mass from the volume. Now, next, I'm going to think about a visual representation. It says that I have 3 grams of mass for every 1 milliliter. Milliliter is volume, so to me that looks like how much space something takes up. We're going to have 5 volumes here, so I'll draw this. 1, 2, 3, 4, 5. So I've got 5 volumes. And my relationship says I've got 3 grams, which we've been representing grams with particles. So here's 3 particles in every volume. So as I'm drawing this picture, I'm also thinking about, well, what mathematical relationship am I kind of doing here? Do I have a bunch of chips that I'm sorting out into separate groups? Well, in this case, I don't know how many chips I have. I'm trying to figure out how much mass I have. Instead, I'm multiplying because I'm saying I have 5 groups of 3. That sounds very much like my 3rd grade daughter learning multiplication right now. It sounds like the definition of multiplication. So when I go to make my mathematical representation, I'm going to start with what I know, the volume. So 5.0 milliliters. And I've got a relationship, 3 grams for every 1 milliliter. So since what I was doing visually was multiplying, or another way to think about it in my relationship, mass is bigger than volume. So my final answer here has got to be bigger than 5 milliliters. I'm going to get that by multiplying by 3, not dividing by 3. So I'm thinking about what my relationship means. And my relationship is 3 grams for every 1 milliliter. So that means I have 5 times as much as just 1 unit. I have 5 times as many milliliters as our unit or our relationship shows. So I will end up with, in my second quantity, 15 grams. So I can't emphasize enough. We're going to take a quantity, the quantity we're given. Quantity has a number and a unit. We're going to multiply it by a relationship that connects 2 different things to get another quantity, in this case in terms of grams. But we're describing the same system in both cases. In our picture, we've got 1, 2, 3, 4, 5 milliliters, 5 equal-sized volumes, and in each group we have 3 grams. So that gives us a total of 15 grams. Just like in the previous example, I'm going to just start by looking at the problem. It looks like what I know is copper contains 9 grams for every 1 milliliter. That for every is a dead giveaway that this is our relationship. It says a small copper statue contains 108 grams of copper. Here we've got a number and a unit. That sounds like our starting quantity. And it asks, what is the volume of the statue? So in my problem map, I'm starting with what the question is asking me for. I want to know, what is the volume? And the quantity I'm given to start with is the mass. And the relationship I have to go from mass to volume, in this case, is the density, the mass for every 1 milliliter. Next, we're going to think about this with chips. Our quantity 1 this time is 108. And it's telling us we've got 108 things, and there are 9 of these grams in every 1 milliliter. So I'm going to divide the 108 out into groups of 9. Also, it's important to notice, like in our relationship, the mass is bigger than the volume. So if I have a mass, I'm expecting my related volume to be smaller than 108, not bigger than 108, because 9 is bigger and 1 milliliter is smaller. So my relationship volume is smaller than mass. So I'm going to take 108. That's a lot of dots to draw, but I'm going to put them in groups of 9. So 1, 2, 3. I'm going to just use dots here. It'd probably be even easier if I just had chips I could slide around. But you can see very quickly why we don't necessarily want to do a picture every single time. So I paused for a minute, but actually it only took me about a minute here. I just started counting from 1 all the way up to 108, but as I drew them, I put them in little groups of 9 because it looks like there's 9 grams for every 1 milliliter. So as I'm circling these units of 9, I'm really figuring out how many groups of 9 can I make when I have 108 grams. And I put 9 grams in each group because there's 9 grams in each 1 milliliter. And if I just count the number of groups, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, it looks like I needed 12 groups. Again, the picture does get a little tedious, but it helps us understand why we're doing the math the way that we are. So again, quantity times relationship. Our starting quantity is mass. And our starting quantity in this problem was 108 grams. The manipulation I did with my chips is I sorted or divided my 108 chips into groups of 9. So there are 9 grams. I'm dividing this time because there were 9 grams in every 1 milliliter. So I really have 108 divided by 9, which is 12 times as much as 1 unit. So my answer, I have 12 milliliters. And the answer I got mathematically is very similar to the answer I got with my visual representation. So you can use both pictures and mathematics to solve these problems.